population of spotted deer found in a national forest is in Hardy-Weinberg equilibrium. For a particular genetic locus found in this deer species, only two alleles, capital A and small a, are possible. If the frequency of the capital A allele in this population is zero point 0.6 and the frequency of small a is zero point 0.4, what will be the frequency of the genotype capital A small a? So, uh, so they are saying that this population is in Hardy-Weinberg equilibrium, and the deer population has two alleles, capital A and small a. They have given the frequency of both the alleles capital A and small a, and they are asking the frequency of the genotype capital A small a, that is the heterozygous population. So first of all, uh, you should know that for if there are two alleles or if there are any number of alleles, so if there is a dominant allele and a recessive allele, the sum of both of those frequencies, the sum of the frequency of dominant allele as well as recessive allele should be equal to 1. If there are more than one alleles or more than two alleles, then also they will follow this principle. The sum of all alleles, the sum of frequency of all the alleles would be equal to 1. So this is one thing. And so from this equation, if there are two alleles and the sum is equal to 1, so if we square both of these, both sides, so we'll get p square plus 2pq plus q square equal to 1, where p is the frequency of the allele capital A, q is the frequency of the allele small a. So here p is the capital A frequency, q is the small a allele frequency, and then we have squared this thing. So p square will be the frequency of the individual with genotype capital A. Q square will be the frequency of individual with small a, and 2pq would be the frequency of individual capital A small a. So from this equation, you can calculate the frequency of the different genotypes of different individuals. If you know the allele frequencies, you can calculate the genotype frequencies. So this uh, this thing or this derivation was known as the Hardy-Weinberg equilibrium. So it comes from the Hardy-Weinberg principle, which states that allele frequency remain constant unless one or more factors cause those frequency to change. So that is why it is called Hardy-Weinberg equilibrium. So when uh, there is no external disturbances or no external factor is acting on a population, then the allele frequency in that population would remain constant. So this is the Hardy-Weinberg equation, and from here you can calculate the different frequencies of the dominant homozygous recessive or the dominant or the heterozygous frequency, and also the recessive homozygous frequency if you know the allele frequencies. So coming back to the question, so our question was to find the frequency of the genotype capital A small a. So we already know that so if we take here, so we have to calculate the frequency of genotype capital A small a, and we can do that, we know that that is equal to 2 into P into Q. Now P here is capital A allele frequency, that is 0.6. Q is small a allele frequency, that is 0.4. Now what we have to do, we have to calculate 2 PQ. So we can take 2 into 0.6 into 0.4, and if you calculate this, you will come to 0.48. So which is option number B. So this is how you calculate the frequency of different genotypes, or if they are saying, if you know the allele frequencies. So the answer would be B, 0.48 for genotype capital A small.